as we continue on into Chapter 10. Our next two lessons, Chapter 10.4 on this one, and then the next video is on 10.5 is going to be looking at trapezoids. We're continuing on with our study of area. When we got into area, we've talked about doing rectangles and parallelograms and squares. We talked about having a base times a height, always having that perpendicular height, that right angle that indicates where the height is going to be and what two lengths we're going to use. We also talked about different types of triangles. We have right triangles where that perpendicular side was, where the 90-degree angle was, and I had a base and a height. And then we also talked about non-right triangles where the right angle was drawn for my height, such as in this case. On triangles, once again, I use the base times the height. But then, because a triangle is always half of a parallelogram, we divided it by 2. So now we're going to come down to this section of our diagram. We're going to be looking at trapezoids. A trapezoid is a shape that has a parallel top and a parallel bottom, but the sides are not parallel. One could be perpendicular, and the other one making an acute angle. On this case, we have one that has 2 acute angles on it, but they're not parallel to one another. That takes our formula just a step further. When we get into 10.6, then we look at even more complicated shapes than a trapezoid. The trapezoid, what they try to introduce you to is the idea that if I take a trapezoid and I flip it and stick them together, I end up with a big rectangle or a big parallelogram. It would be the 2 trapezoids together. It's kind of like the idea of taking our triangles, flipping one, sticking them together, and getting a parallelogram. I find that really complicated though to do, and it's just extra work when I have to find the shape of a parallelogram that I'm not even going to use, and then I have to find what the area is of the trapezoid. So what we're going to focus in on is the formula in which they give us. Once again, it's this bottom portion that we're talking about. Still having to have a perpendicular angle to find my height, and going to have one set of parallel sides, so we're going to do this formula. When I break this formula down, what it says is, in the book you're going to see something that say to multiply by 1/2. We're going to stick with the idea, like we do with triangles, of dividing by 2, unless it's one of those problems where I just really have to use the 1/2. We're going to focus in on this formula right here. It tells us that I have a base 1 and a base 2. And that's because on my parallel sides, I have different measurements. So my base 1 is at the bottom and my base 2 is at the top. Now I'm going to tell you mathematically, it doesn't matter if you put the top first and then add it to the bottom. You can have the numbers switched inside the parentheses. It's not going to change your math because that's the way math works. Once again, in addition and multiplication, I can do it in any order. I still end up with my same number. So don't get caught up on, well, which one is the base 1 and which one is the base 2. It really doesn't matter as long as you know that you have to take the 2 bases, the top and the bottom, since they are different lengths. So I take the top and the bottom, the base 1, the base 2, and I add them together. Then, once I have that total, then I multiply by the height. And once again, that floating dot just means to multiply. And my height always will be given by a right angle. Sometimes it'll be drawn on the outside, sometimes it'll be drawn on the inside. But I can't have a height unless it's a right angle. Notice they give me the angle or the measurement of this side. That's just to trick you. I don't need that. The only time I would need that is if I'm finding the perimeter around this shape, which that's not what it's asking me to do. So once I add the base 1 and the base 2, so in this situation 6 plus 2, I'm still going to set up my formula where I know I'm going to multiply it by the height, which is 3, and then my final step is to divide by 2. 6 plus 2, I always do my parentheses first. That's my order of operations. Inside parentheses, then I have 6 plus 2, which is 8. 8 times 3 is 24. My last step is I have to divide by 2. It is a trapezoid, which means I have to divide by 2. It's not 2 shapes that I'm putting together. And that would give me that the area of this trapezoid is 12 square inches. Once again, anytime I find an area, my label is always squared. Don't forget that because it's important. Every label on your answers is worth a point. And if you don't say it's squared and you just give me a base unit, I have to count it wrong. So when I look at what it's talking about, one of the trapezoids, it explains that the right angle is going to be drawn and that that's 90 degrees, that I have a base 1 and I have a base 2, and how a basic trapezoid is set up. Trapezoids are always quadrilaterals. And think about what that word means, quad. If I talk about a quad runner, I'm talking about a off-road vehicle that has 4 wheels. If I talk about a coordinate plane, Q-U-A-D, I know I have coordinate 1, 2, 3, and 4. If I talk about a quarter, Q-U-A-R, then I'm talking about 1/4 of something. So the Q-U-A is always going to be 4, so quadrilateral is a 4-sided shape. Trapezoids are always going to be 4-sided shapes. So what they introduce us to, the idea is that if I take my trapezoid and I double it, so I cut it out, I make a second one, that when I stick them together, I end up with a parallelogram. And I don't mind that concept, and it's a good concept to understand that all sorts of shapes can be manipulated to make different types of shapes, but I'm not going to spend the time to try to figure the area of what that parallelogram is going to be when it doesn't really apply to what I need you to understand or what you're even going to be doing on your homework. So we're going to be skipping those where it says, well, define the area of the parallelogram before we find the area of the trapezoid. We're going to jump right into finding the area of the trapezoids. When I look at this one is one of those trapezoids that I said it could have. This one does have a straight side. It is perpendicular to the base, and the base, it is not parallel with the side. So that's why it's a trapezoid. Trapezoid has one set of parallel sides, and opposite sides then are not parallel. When I look at the formula that I'm asked to do, base 1 plus base 2 times the height, always then divided by 2. So when I look at my bases, it's the top and the bottom. I take my base 1, which is 9, and my base 2, which is 5. So I understand that this is having you do something different. This is wanting you to find the area for the rectangle that it would create. Not focused on that. So over to the side, I just want you to write this out. We're taking the original formula that we're going to be dealing with. Base 1 plus base 2. That's inside of parentheses because I have to do that first. Times my height, divided, because that fraction line always tells me to divide, by 2. So if I fill in the information, once again, I have 9, base 1, plus 5 in parentheses, because that's my base 2. Then I'm going to multiply them by my height, and once again, my height is always indicated by a right angle. So when I have my height, then I'm going to divide the final work by 2. So then I do my parentheses first, and 9 times 5 is what? 14, right? So I'm going to have 14 now times 3. When we do these, once again, show me the formula, show me the work that we're setting up, get your handy-dandy calculator, multiply them together. It's a lot easier, and these won't take nearly as long if you're using your calculator. It also is going to eliminate a lot of silly mistakes when you're trying to do it in your head. I'm not asking you to do mental math. I don't want you to do mental math. I want to see this work set up so I know what you're doing, and then type it into your calculator. 14 times 3 gives me 42. It's still going to stay over 2, because once again, my last step on at finding the area of a trapezoid, I have to divide by 2. Once again, on some of the formulas in your book, you're going to see it says to multiply by 1/2. Anytime I'm multiplying by 1/2, of, as I said on the triangle videos, it's still the same math. I'm dividing by 2. So 42 divided by 2, set up my little division box. 42, the numerator always goes inside. My divisor is always going to be my denominator. So I have my dividend, I have my divisor, my quotient, my answer when I divide is going to be 21. Once again, squared labels, squared centimeters. So once again, that should be written out to the side. If you need to pause the video before I move on, please do so. Going on to the next one then. So we're going to jump into just doing the practice problems. One of the things about these types of formulas is you can learn them and memorize them, but if you don't practice and work with them, you get really confused. One of the nice things that you're going to see on your homework, you're going to see on NWEA, you're going to see on Moby Max, you're going to see on the I-STEP test. They give you these formulas. So when you see the word trapezoid or you see the shape trapezoid, then all you have to do is find the formula itself and remember how to use it. Using it is the key. Memorizing, it's good to know, but I'm not going to force you to memorize a whole bunch of formulas. I need you to understand how they work. That's the whole key to mathematics and being successful in math. I don't remember every single formula I ever learned through algebra and analytical geometry and Euclidean geometry, but I can go back to those formulas and look at them and remember how to use them. That's what I want you to know. So what I want you to do first is I want you to copy this down, please, in the practice problem area. Just write it at the top. I want you to have this formula. We're going to take base 1 plus base 2. Once again, those go in parentheses because you know you have to find that first. Multiplied. Now, if you don't like the floating dot for multiplication, that's fine. Put an X, as long as you know it's not an X in the letter. It's a multiplication sign. Times the height, and then all of that is divided by 2. It's important to have this on your paper so you can constantly look back at it as you're doing your work. Once we have that written down, this tells me things to do. Trace and cut out 2 copies of the trapezoid. Arrange the trapezoids to form parallelogram. Find the areas of the parallelogram and 1 trapezoid using square units. All I want you to do is to find the area of the trapezoid. In order to find the area of the trapezoid, we have to have our basic information. So go ahead and show your basic information. What is the base 1? The base 1 at the bottom, when you count, 1, 2, 3, 4, 5, 6, 7 boxes are used. When I go to my base 2, which is at the top, 1, 2, 3, there are 3. I've shown that. And then I did the dotted line with my right angle to indicate that I know that's my height. And my height takes me from bottom to top, which is 4 units. Then I'm going to plug it into the formula that I have. So I'm going to take base 1 plus base 2. That gives me 7 plus 3. I want to multiply it by my height. My height is 4. So it's showing multiplied by 4. And then I know I'm going to divide by 2. When I do my addition on the inside of my parentheses, 7 plus 3 gives me 10. And that leaves me with 10 times 4 divided by 2. So then I do my multiplication in my numerator. 10 times 4 is 40. Still leaving me with the dividing by 2. And then 40 times divided by 2 is going to give me 20. So my answer for my area of this trapezoid, is going to be 20 square units. Doesn't give me a specific measurement, so I know I'm going to use units as my label. Let's look in at number 2 then. Once again, I don't need you to find the area of the parallelogram. I need you to find the area of the trapezoid. Going to use this formula every single time. What is my base 1? And what is my base 2? My base 1 is 10. My base 2 is 6. Once again, if you put those in the wrong order and you list 6 plus 10, mathematically it doesn't change anything at all. As long as I add those two together, 10 plus 6, I know I'm going to be on the right path to solve my problem. My height then is 5, so I'm going to multiply by my height. And then the whole thing, final step will be dividing by 2. So then I do parentheses first. Order of operations. Ask for several extra presents, your absolute value, square roots, exponents, parentheses have to be done first. Then, my dear, multiplication and division from left to right. Aunt Sally, addition and subtraction from left to right. Parentheses first, 10 plus 6 is 16, multiplied by my height of 5, leaving the division by 2. 16 times 5, 16 times 5 equals, you get 80. 80 divided by 2 leaves you with what? 80 divided by 2 gives you 40. So I know my answer for my area of this trapezoid is going to be 40. They give me my labels of square centimeters. Notice on some of these practice problems, they start out, they give you a label, and on some they leave it off. So if it's left off, you have to include it in your work. Going to question 3 then. Same formula. Once again, every time. Base 1 plus base 2 in parentheses times my height divided by 2. And look at the information I'm given. I have 3 and 9 for my bases. So I'm going to take 3 plus 9 in my parentheses. My height, there's my right angle, so I know it's my height. So I'm going to multiply my height, which is 8. Last step would be to divide by 2. Parentheses first. 3 plus 9 is 12. 12 times 8 is what I'm left with, divided by 2 for my last step. 12 times 8 is 96, divided by 2. And so I set it up. Numerator inside the box. Denominator is my divisor. So my dividend divided by divisor gives me a quotient, or an answer to my division problem, of 48. So I know the area for this trapezoid is 48 square inches. On number 4, I have a base of 5 and a base of 11. Starting back with my formula again, formula should be listed at the top of your paper, and fill in the information that you know. My base 1 is 5, my base 2 is 11, those go inside of parentheses. I know I'm adding my bases together. Then I'm multiplying by my height. Once again, my height is indicated by a right angle. So I'm going from top to bottom, so I know it's a height of 8. So I multiply by 8, and my last step will be to divide by 2. So I do my addition on the inside. 5 plus 11 is 16. I'm left with 16 times 8 divided by 2. Once I multiply those together, 16 times 8 equals, I have 128 divided by 2. And when I set those up, dividend, divisor, numerator, denominator, divide those out. 128 divided by 2 is 64. 64 what? 64 square feet. Now, if I went too fast to work this out, please pause and fill in your book. Here's the problem some of you are going to get into. It's a few steps that you have to show. And you're not going to want to show it because you don't want to put forth that extra effort in what is required. Please understand, and I can't stress it enough, there isn't any reason why anyone should not do well on the I-STEP test, because I teach you everything you need to know. Generally, a lot of points that are missed is because they just don't want to show the work. And showing the work is worth more points than the answer itself. You have to show the steps. I require you to show the steps. If you have every answer correct on your paper and you don't show me any work, the best you're going to get is a 50%. Is this a lot of work? It's not a lot of work. Is it a few steps? Absolutely. But you can do it because it's not difficult at all. So simply do as I ask you to do and I expect you to do, and you will be successful. Going on to the next set then. Once again, if you're not ready and you didn't get it all filled in, then please pause the video before you work on. I have 5, 6, and 7. They give me my labels. I once again am going to use the same formula every single time. When I look at number 5, then I know I have my bases. I have a 22 and a 16. The height is already drawn as a perpendicular, so this is a right-sided trapezoid. When I plug in my information in parentheses, I take my base 1 plus my base 2, put them inside of parentheses. I show them I want to multiply by my height. They tell me it's 14. And then I'm going to divide by 2 as my last step. When I add those together inside my parentheses, then I get 38. And 38 then would be multiplied by my height of 14. Last step, once again, always to divide by 2 for an area of a trapezoid. 38 times 14, type it in, equals 532. 532 goes inside my division box. Top number always does. My numerator is always inside my box. Once again, some of you get a little confused on the calculator when you go to type those in division also. What's inside the box or the numerator is always typed in first as well. You remember it usually if you leave it as a fraction when you type it in, but I do have several of you that when you have the division box, you type them in the order that they're listed, but you have to remember what this is saying. This is not saying 2 divided by 532. And if you type it in that way, you're going to get a completely weird answer, a very big decimal. 532 divided by 2 is what it says. So that's the order you have to type it in. 532 divided by 2 equals, that's going to give you your answer of 266. When I put it back on my line, my label's already there, so I know it's 266 square centimeters. On number 6, same formula. Information is given. I have my base 1, I have my base 2, I have my height because there's my right angle. So I'm going to fill in my formula and set up my original math problem. I'm going to take my 14 millimeters and my 8 millimeters inside of parentheses. I have my 14 plus 8. My height is 6.5, so I have times my height of 6.5. And my last step, once again, is to divide it by 2. Once again, why we divide it by 2? As they show you on every single one of these problems, these dotted lines are showing you that they would make a parallelogram, and we don't need the whole measurement of a parallelogram, we just need the measurement of half of it. That's why it's times by 1/2 or dividing by 2. So I do the math inside the parentheses. I end up with 22 because 14 plus 8 is 22. I know I'm going to multiply that by 6.5. Then I'll divide by 2. And when I multiply 22 times 6.5, I hit my equal sign, I get 143. 143 goes inside my division box. Divided by 2, type in 143 divided by 2, and I get equals to 71.5. 71.5 what? 71 and 5/10 square millimeters. Now, if you see that, and when you divide out, you end up with 71.5. Is that the same thing? Absolutely. I will accept 71.5 also. If you prefer to show it as a fraction, then please show it as a fraction. I bring that up because this one is set up as a fraction. That gives us extra work that we have to do, but I can still write my answer as a decimal if I prefer decimals in my answer compared to fractions. So let's look at what we have. We're given mixed numbers once again for my bases as well as my height. So I have 8.5 plus 3.5. When I add, or then I'm multiplying by a height of 5 1/4. So when I start looking at math that I have to do with fractions and mixed numbers, I start with my addition because it's in parentheses. Can I add fractions and mixed numbers? I can, right? As long as my denominator is the same, I'm good to go. And in this case, I have denominators of 2, so I know a half and a half makes what? Makes 1, right? If I eat a half a pizza for lunch, and I eat a half a pizza for supper, and I talk about it in the evening, I ate an entire pizza. So when I add those together, I end up with 8.5 plus 3.5. That gives me 12. Because 8 plus 3 is 11, and my half and a half makes 1 more. 11 plus 1 is 12. So then I'm taking my 12 and I'm multiplying it by 5 1/2. Can I multiply whole numbers and fractions and mixed numbers? And I can't do mixed numbers, can I? I can't do whole numbers. So I know I'm going to have to change this whole number. But I'm also going to have to change this 5 1/4. And we've done that on the past several videos. We've been doing that for a couple months now. So I know I'm going to take my 5 1/4 and I have to make it an improper fraction. That's where I start at the bottom and I multiply and then I add. So I have 5 times 4, which is 20. And 20 plus 1 is 21. And I keep my denominator of 4. So I'm going to use 21/4 in my math problem. So I have 12 over 1. That comes from adding my base 1 and base 2 together, ending up with 12. But since I'm multiplying by an improper fraction, I have to put it over 1. Times 21 over 4, I still show that my last step when I get done is to divide by 2. Can I cross reduce? Now once again, you don't have to cross reduce. But if I can cross reduce on a math problem, I'm going to show you to cross reduce. It's going to give you smaller numbers. It's going to make your math easier in the long run. So I can cross reduce. 4 does go into 4 one time. 4 does go into 12 3 times. So I'm going to cross reduce and change those. So when I multiply straight across, I end up with 3 times 21, which is 63. 1 times 1, which is 1. And we ought to know by now that 63 over 1 is just 63. So my last step is going to be to take the 63 that I ended up with, and I'm dividing by 2. Going to go back through that step one more time so you understand what I'm saying. So when I change, or when I added these together, I end up with a whole number of 12. I know I'm going to multiply by my height of 5 1/4, but I can't multiply by mixed numbers. It has to be in fraction form of an improper fraction or a straight fraction. So when I look at my fraction, I'm going to change my 5 1/4 into an improper fraction by multiplying, gives me 20, then adding, which 20 plus 1 is 21, and I keep my denominator 4. So I have my 21/4 that I'm multiplying my 12 by. And since I can't multiply a fraction and a whole number, I put my 12 over 1. Up here I do my work and I see if I can reduce, cross reduce, and if I can I will, and then whatever my number is, that's going to be my numerator. I could end up with a fraction, which changes how my format's going to be a little bit, but those won't come until later on in the school year. Right now they're going to give us nice easy whole numbers once we reduce. So I reduce my 4 and my 12. 4 once again goes into 4 once, and 4 goes into 12 3 times. And then I multiply straight across. 3 times 21 is 63. 1 times 1 is 1. 63 over 1 just gives me my 63. So that's where the numerator came from. My 2 I just carry over. I'm still going to divide by 2. When I divide my numerator by my denominator, my dividend divided by my divisor, my answer, or my quotient, is going to tell me that I have 31.5. Now, once again, if you want to do a fraction instead, since it starts as a fraction, it doesn't tell me my answer has to be in a fraction, so it's really up to you. I will take 31.5, or 31 5/10 square inches, or I'll take 31.5 square inches. It's up to you on how you want to write the answer, because they're the same value, and I don't care which one you use. So let's look at this shape then. On number 9, we're skipping number 8. It says a patio is in the shape of a trapezoid. The length of the longer base is 18 feet. The length of the shorter base is 2 feet less than half the longer base. The height is 8 feet. What is the area of the patio? So I'm given my base and I'm given my height, but I have to find my second base, right? And that gets a little wordy on what it's telling me. I know that I have 18 plus something, and then I'm going to multiply it by the height of 8 and divide by 2, because that's my formula for a trapezoid. But what is my other height? So I know that it is 2 feet less than half the longer base. 2 feet less than half the longer. So that tells me that I have 2 math problems I have to do. And which one am I going to do first? Well, if it's 2 feet less than half, I have to find the half first. So I'm going to take and find out what 1/2 of 18 is. Then I can subtract 2 from it. So when I take 1/2 times 18, once again, it's the same thing as dividing by 2. So 18 divided by 2 tells me I'm dealing with 9. And if it's 2 less than half of the longer one, 9 minus 2 tells me I'm using a measurement of 7. So now I can plug that 7 in here. I have 18 plus 7, multiplied by the height of 8, divided by 2, then I can move forward like I have on all the other problems. So I have 18 plus 7, which gives me 25. I'm going to multiply 25 by 8. Now, if you want to do a quick calculation in your head, then you would say, well, I know that 4 quarters is $1, and 8 quarters is $2, which is 200 pennies. Or just take your handy dandy calculator, 25 times 8 equals, and it's going to tell you it is indeed 200. 200 then divided by 2, my last step, numerator divided by denominator, it tells me that my answer is going to be 100. 100 what? 100 square feet for my area. What about this problem? Well, this problem talks about Nevada. It says that there's a little bit of a difference, but we're going to estimate the general area for this shape. But we don't have to do the work, do we? We have to figure out where she messed up. Now, why are we doing this? We're doing this because for at least the last 6 years on the I-STEP test, you've been given a problem that you have to find errors in and correct to get to the right answer. So if we practice on how to do that, it becomes a lot easier. So let's look at the work that Sabrina does. So Sabrina takes the length of the rectangles. Well, we have 200 and we have 480. So if we look at the shape here on the map, I have my 200, that's my base 2. I have my 480, that's my base 1. I'm good with that. And then I get 680. My width, well, that's also known as my height, because there's my right angles, is 300. And she multiplies those by 300. So I would take 680 times 300, and I get 204,000. 204,000 what? 204,000 square miles. Is she correct? She's not correct, is she? So what did she do wrong? Did she forget to do something wrong, or is her math wrong? Well, her math is correct, but she found the area of a parallelogram, because this is a trapezoid. Nevada is indeed a trapezoid. So I have to remember what I'm doing, and then I have to use words to describe before I find the answer. So where Sabrina messed up is Sabrina forgot to divide by 2. That needs to be written in your book, because when it asks you to explain or to describe, you have to use words in your answer. So when I divide by 2 for my last step, now I can show work to find the area. 204,000 divided by 2 gives me 102,000. 102,000 what? 100,002 square miles would be the area for Nevada. On this one, a photo was cut in half at an angle. What is the area? What is the area of one of the cut pieces? So they don't care which area that you're figuring out, but I would suggest do the pink one because it gives you the measurements. Now, that should also tell you that these measurements would be the same, because if it's a rectangle and cut in half that way, you know they're going to be the same for your trapezoid. So when I find the information, I'm going to fill in the same formula. Now, I didn't put the formula on this one because we should remember what it is. So the formula once again is base 1 plus base 2 in parentheses multiplied by my height. Then it's all going to be divided by 2. So my base 1 of 7 plus my base 2 of 3 multiplied by my height of 6. There's my right angle. Always then dividing it by 2. I end up with 10 times 6, and 10 times 6 is going to give me 60. 60 divided by 2, numerator divided by denominator, I know that I end up with 30, and when I put it up here, I make sure, since it's an area, I square my label. So I would have 30 square inches. Now, we do have one question that I need you to understand how it works, which we really didn't talk about and haven't talked about, even though it connects back to the idea of rates and ratios and plotting them, which I believe, if I remember correctly, was 4.6. I may be off on that, but I believe I'm correct. So you have your extra sheet. You have this information here. You have the question that's given to you. What is the equation for the graph when solving for y? Now when I look at that, that might get a little confusing, but I'm going to walk you through it. So please follow along and focus on this. Do this because you have a homework assignment, not identical, but very similar to. So when I'm doing this, I look first at where are all the points where the lines or the diagonal line crosses at an actual point on the grid. So I always go through and put points on there. The book doesn't show you to do that, but that's what I learned to do when I was in college doing calculus and Euclidean geometry, is always to indicate where they are so that I can find them easier. So when I'm going up from my point of origin, they cross at 3 and I put a point. They cross, intersect at the 6, and then they intersect at the 9. And when I say cross or intersect, I mean it's where a y and an x are crossing one another at an actual point. I go down and I see the same thing. They're going to cross at -1 and -3. They're going to cross at -2 and -6. And they're going to cross at -3 and -9. So how does that help me solve for an equation? Well, if we remember how we plotted rates on a graph, I'm going to have that same type of information set up. So I've given you a rate or ratio box. And we should remember, because this is going to be important, not just in 6th grade, but also throughout middle school and your first couple of classes of high school math, that my x is always on bottom, my y is always on top when it comes to having these set up in a chart before I graph them. So let's look at the x's that I end up with. Going from my origin, I end up with 1, 2, 3. So I've listed those. And then going back from my origin, I have -1, -2, -3, and I've listed those. Because once again, when it comes to points on a coordinate plane, I'm always going to run first. Positive, I'm running forward. Negative, I'm running backwards. Then I look at where it connects with a y. So when I go to 1 and I look at the y, I'm going up to a +3. So notice I went to a 3. The 2 goes up to the 6. So 2 and 6. The 3 goes up to the 9. So 3 and 9. And then when I go to my negatives, x first, -1, jumping down to -3. My -2 takes me down to -6. My -3 takes me down to -9. So I have all of that information plotted out. Do you see a pattern? I'm hoping you do. Because what I see is every time, if I take my x and I multiply it by 3, I get my y. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Now I understand we haven't gotten into integers and how we multiply integers and what that gives me, but I'm telling you, that math is correct. -1 times 3 does give me -3. -2 times 3 does give me -6. And -3 times 3 does give me -9. So I know I'm solving for y, so my y, and it's an equation, has to be equal to something. So I put the definition at the top of your paper once again, that what an equation is. It's a math formula with an equal sign. So my y is going to be equal to, every time, 3 times my x. Doesn't matter what x is. If I multiply it by 3, then I know what my y is. If I'm talking about an x of 15, then I know, and yes, it would be off my chart, but I know that if my x is 15, I multiply it by 3, then my y is going to go all the way up to a +45. So once again, you have a homework assignment very similar to that. So I would take the 3 minutes maybe that it took me to explain that, to go back and watch it just so you truly understand it before you get into your homework. But that's our lesson. Our lesson is just understanding how this formula works. Yes, in your book you're going to see some of the formulas that say to use 1/2. It doesn't matter, because multiplying by 1/2 once again is dividing by 2. So if we stick with the formula of base 1 plus base 2 times my height divided by 2, it's going to give me my area of my trapezoid. Work through it, rewatch it if you need to, look at your homework on the board. If you have any questions, come back to me and ask.